Okay, I would like to go over an example problem from Chapter 4. This is finding the moment of a force about a line. This is a very important concept that you need to know, and we'll look at all of the steps needed to find this moment of a force about a line. In this problem, it states that the system shown is commonly used for supporting a rural mailbox. It has the feature that the mailbox can swing about line A if it is subject to a z-directional force, preventing possible damage to the mailbox and supporting posts. Line A lies in the xy plane. The 150 Newton force acts in the y direction, and the 200 Newton force has the direction specified below, and the lines of action of each of these pass through point C. This is point C here, where both of them will go through. We're supposed to determine the moment of the 150 Newton and 200 Newton force about this line A. And it states that the 200 Newton force acts in the z direction, or z-axis direction, and again the 150 Newton force acts in the negative y direction. Okay, so let's look first at the steps that we need to do to solve this problem, and that is finding moments of a force about a line. The first step is, in this process, is to find the vector expression of the force that we want to know the moment of the force about that line. So for our example, we can look at this force F. We know we have 0 in the I direction. We are told that there's a minus 150 Newton force in the J direction and a 200 Newton force in the K direction. So that is our vector expression. Sometimes we have to use, if you remember, sometimes we will have to do things to find our force. We may know the magnitude in a cable or something. We need to multiply it times a unit vector, which would be some position vector divided by the magnitude of that position vector. That will give us a force in that direction. This one, though, is fairly easy to do. Step 2 in finding the moment of a force about a line is to find the position vector r from some convenient point P, or in our case A or B, that is on that line to some point of the on the force's line of direction or line of axis, right? So if we look at it, the only point that we know for the force is point C. So we are obviously going to choose point C as one force or one point, and then we need some point along line A to point C. Okay, so for the second step in this process, we need to find a position vector. R, of course, is our position vector from some convenient point P on the line to some point on the force's line of action. So if we look at this, the only point that we know for the force's line of action is point C. The other ones can be any point along this line. Well, we are given only points A and B, and it really doesn't matter which one we do, but we will use one of those to point C. So for our example, we are going to take this particular position vector from A to C. So this is our position vector R, A, C. And we're easily given or nicely given these points A, B, C, so it makes it easy for us to find our position vector. So position vector R, A, C is equal to the head minus the tail. The head is the arrowhead end, so C minus A. So we are given 115 I hat, plus 18 J hat. And there's nothing in the z direction, so there's no k hat. This is centimeters. That is our position vector, RAC. Step 3 then is to find or compute the moment about some point, and that is our point A in our case. So we are going to look for the moment about point A. So when we compute this moment, this MA, we will know that that is a vector, right? It is a vector. So let's do that. And we will use, again, the cross product to solve for this. So we will find MA, which is a vector, is RA, which we just found, cross F. I, J, K. The I, or the position vector itself, is 115, 18, and 0. If we look back up, our force vector is this one, which is 0, negative 150 plus 200. 0, negative 150 plus 200. And I'm not going to go through the math on solving all of that, but we will find out that our vector MA is equal to 3600 I hat minus 23,000 J hat minus 17,250 K hat. And the units on that are Newton centimeters. The next step, so now we know the moment. All right, we know this moment, some moment off of A. We don't know where it is or how it is, but it's out here somewhere. This is our MA, we will call it. And what we want to still do is find out what is that moment about that line A. So remember, when we want to find a force or a moment that acts in a specific direction, we use the dot product. And what we need for that dot product is a unit vector, so some small unit vector in that direction. So we'll need this unit vector AB. To find unit vector AB, we will again need our position vectors that we have. So step 4, let's write that down, is to find a unit vector along the direction of the line. So in our case, again, to find this unit vector, I'm just going to write it up here so we can kind of see it with the diagram itself. This unit vector AB is equal to a position vector AB divided by the magnitude of that position vector. So we know AB, if we take the head minus the tail of A from A to B, so B will be our head. In this case, we will get 5 I hat plus 12 J hat divided by the magnitude of that, which is 25 plus 144 square root, and that will give us 13. That is our unit vector that we will use. So now, knowing this unit vector, we are going to use that, and we found UAB, right? We said, I'm going to write that down real quickly. That is equal to 5 I hat plus 12 J hat divided by 13. The next step in our process, and actually our last step, is to determine the component of that moment, MA, about that line in that direction. And that's just using the dot product. So this is our last step in this process. So let's do this again. We're finding the moment Using the moment MA, which is on the line, find the component of that in the direction of AB using the dot product with the unit vector. So for our problem, MAB is equal to MA, which is a vector dotted with our unit vector AB. Our moment was 3600 I hat minus 23,000 j hat minus 17,250 k hat dotted with our unit vector. Okay, and when we do our dot product, remember we just multiply like terms. So this I term times 5/13, the j term times 5/13. There is no k term, so that will go away. That leaves us then with a moment MAB equal to negative 19,850 Newton centimeters. Realize that a few things about this moment. One is that it's a scalar value. At this point, it is not a vector, but a scalar value, and it's telling us that it is negative. So if I go back on here, and if I put the base of my hand at A, point my thumb towards B, we see that we're getting a positive moment that would go in this direction, but this 200 Newton is actually going in this other direction, which is a negative moment around it, based on the way we have taken our unit vector AB. So this seems to be a logical solution. All right, that is the process for finding moments of a force about a line. You will need to know this for the exam.